The ancient Indian texts mention beautifully decorated chariots or entire palaces called vimanas that could take off and, in a matter of seconds, fly away as far as space. Some people believe these vimanas only existed in Indian mythology, but it's also possible that they were based on a real technology that had been lost over the centuries. According to the Vedas, ancient Indian religious texts, there was the elephant vimana with several engines and many other types named after animals and birds. There was one for local travel, one for visiting different countries, and one for traveling to the moon and various planets. They could develop a great speed. One vimana had the superpower of invisibility. Another one was shaped like a sphere and was built on the winds produced by Mercury. This vimana was said to generate an enormous ray like the sun and make noise like the storm's thunder. All the vimanas were unbreakable and perfect for attacks on foes. Now, to operate a vimana, you'd need to know a lot of stuff, pretty much like today's airplane pilots, 32 secrets in total. They'd cover the aircraft structure and the secrets of taking off and maneuvering without crashing. That's a good thing. The pilot was also expected to know how to be seen and unseen, how to be hidden, how to be quick, how to manage contractions and expansion, and many other tricks. To hide the flying machine from foes, the pilot was instructed to move to the 8th atmospheric layer above the Earth and use the power of dark solar rays. This instruction might sound a bit weird, but there were others, more realistic ones, which still make sense in modern aeronautics. There are sections of ancient texts on the vimanas that focus on details like flight paths, pilot training, navigation, and even suitable clothes for pilots and recommended food for long flights. There was also a lot of technical detail about the use of heat-absorbing metals, the metals utilized, and melting points. The supporters of the theory that the vimanas were more than just myths are sure that the ancient Indians would unlikely go into all these details just for a beautiful story. So, the flying palaces might have been real and way ahead of their time, like many other great Indian inventions. Back in the 6th century BCE, an Indian physician named Sushruta basically wrote the original guide to medicine and surgery. They even called him the father of surgery for his work. Sushruta laid down the details on hundreds of medicinal plants and described complex surgical procedures. He gave instructions on nose reconstructions and skin transplants from one part of the body to another. The original method of rhinoplasty, which involved taking a piece of skin from the forehead to reconstruct the nose, is still used today. But back then, it had a slightly different purpose than surprising your followers on social media. Those nose jobs helped out folks who had lost their noses as punishment for crimes or in fights. Now, you gotta thank an ancient Indian math prodigy for the invention of zero. It might not seem like a big deal, but without it, we would have no binary system and no computers. People before the 5th century CE were only thinking about some sort of a sign to indicate nothing. The invention made addition, subtraction, and other mathematical operations a whole lot easier. You can see the oldest zero in existence carved in the wall of a temple in Gwalior, India. The Indus Valley Civilization was using rulers in 1500 BCE and earlier. Made from ivory, these rulers were found during excavations in what is present-day Pakistan and northwestern India. They were widely used in architecture with amazing accuracy. They had units corresponding to slightly over 1 inch that were marked with precise subdivisions within 5/1000ths of an inch. The next invention is more of a concept than a physical item. Standardization is all about setting the rules based on a bunch of people, things, or interests. One of its cool applications that we've all gotten used to is standard weights. Whether you're using pounds or kilograms, you need these universal measurements for weight, right? For this, we owe a big shout-out to the merchants from the Indus Valley Civilization who lived around 4,000 years ago. They were measuring everything from food grains to fancy luxury goods using these standardized weights. And their weights had decimal and binary mathematical systems going on. They didn't have high-tech gear. but they pulled off some serious precision using complex calculations and even sand for construction. Their art of standardization made its way to Persia and Central Asia, basically becoming the global weight-watching standard. So, if yoga is your go-to exercise, you definitely have a personal reason to appreciate the ancient Indian geniuses. Over 5,000 years ago, during the rule of the Indus-Sarasvati civilization in northern India, yoga was first mentioned in the Vedas. Yoga was refined and shaped over the centuries until it grew into a massive teaching with over 200 sacred writings dedicated to this way of obtaining enlightenment. At the beginning of the current era, yoga got a new trajectory thanks to a Hindu writer who laid down a system of yoga in his text, the Yoga Sutras. It became a whole-body rejuvenation, a life-extending practice with poses that you are still doing on the mat today. Yoga has reached the Western world only in the 19th century, and it caught on like wildfire. Chess, the all-time top game for intellectuals, is also an Indian invention. Its ancestor was called Chaturanga, and it was a strategic board game that started gaining popularity around 3,000 years before the current era. This early Indian version of chess was played by 4 people, not 2, and had 64 squares. Each player had 8 pieces, ranging from pawns to kings, bishops to knights, and there was no standard 6-faced dice. They rolled with an oblong one. Players facing off were actually allies, forming 2 teams based on the direction they sat. Chess, that we know and love today, was first mentioned in ancient Indian literature in a legend. It said that the wife of a villain called Ravana had invented the game to amuse him. Now, the word shampoo comes from the Hindi word, which means to soothe or knead. The substance was invented in India in 1762 and was originally used for head massages, hence the name. The first shampoo was made of natural oils and herbs. British traders fell in love with the idea and brought it back with them to England. It took years for the original head massage oil to evolve into shampoo as we know it today, but it's still an Indian invention. Unlike the ancient Greeks, who wore animal skins, the Indians started cultivating cotton back in the 5th and 4th centuries before the current era. They used cotton threads to produce fabrics that soon became a huge hit in the Mediterranean and beyond. Jute and wool also have their origins in India. Cashmere, the finest and most exclusive type of wool, actually comes from the Kashmir region of India. Buttons that sit proudly on that cashmere cardigan of yours also have ancient Indian origins. Some 5,000 years ago, the Indus Valley civilization started cutting seashells into geometric shapes with tiny holes in them. First, they were just decorations, but then people started using them to fasten clothes. Now, when you think about radio communication pioneers, Marconi's name usually steals the spotlight. He got a Nobel Prize in Physics in 1909 for his groundbreaking radio work. But there's an unsung hero in the radio waves game, and his name is Sir Jagdish Chandra Bose. He spilled the beans on radio communication way back in 1895. He shot an electromagnetic wave across 75 feet at the town hall in Calcutta, and it went through walls, rang a bell, and even set off some gunpowder. Marconi took a page from Bose's book, using his invention, the Mercury Coherer, as a blueprint for his own two-way radio. Bose didn't patent his genius creation, so he only got his credit a century later.
In 1936, British Egyptologist Walter Bryan Emery found a small object in the desert that made people debate whether it was an elaborate stone model of a flying saucer or even a hyperdrive from a spaceship that belonged to some advanced civilization that visited the Earth. Emery spent years excavating sites along the Nile River Valley, especially in the huge ancient necropolis of Saqqara. He found countless treasures from ancient Egypt, and the most bizarre one was definitely from the tomb of a high official, Sabu. Historians don't know exactly who he was for sure. Some sources say he was a king's son. His burial at Saqqara means he was an important figure in the royal court, There are no records from this early period he lived in, so Sabu's role and fate are still a mystery. Inside his tomb, scientists found 7 funerary chambers, each filled with traditional grave goods: animal bones, flint tools, pottery, ivory objects, and stone bowls. And then there was a strange, broken artifact that became famous as the Disc of Sabu. It resembles a shallow, round-bottomed bowl, but with 3 delicately carved, curved lobes spaced roughly 120 degrees apart around its perimeter. These lobes are separated by 3 holes, and at the center, there's a thin tube. The material used to build the disc is meta-siltstone, or schist. This type of rock is fragile, highly porous, and super difficult to carve. It flakes easily and crumbles under pressure. So how they made the disc out of it with rather simple stone and copper tools from 3000 BCE is still a mystery. The next big question is why they decided to bury Sabu with it. Perhaps if we knew its true purpose, it would make more sense. When it was first discovered, archaeologists thought it was nothing more than a vase, an incense burner, or a ceremonial decoration. But those who took a closer look from the point of view of an engineer decided it could actually be a component of a larger mechanism. An amateur historian made an exact copy of the artifact with a 3D printer, and it turned out that the Disc of Sabu was an ancient impeller, a crucial part of a centrifugal pump. When they put it in a housing and span at high speeds using the small central shaft, the disc was able to displace water. When it was tested without a housing, the disc created a powerful vortex. It became clear that the curved lobes and slightly concave shape of the disc weren't random. It was probably all engineered to move water with remarkable efficiency, like a powerful pump mechanism. Ancient Egypt's entire civilization depended on irrigation. Later dynasties perfected basin irrigation and managed to control the rise and fall of the Nile to take the most from agriculture. So, the engineers of the first dynasty may have been experimenting with advanced irrigation techniques thousands of years earlier than scientists previously thought. But then again, some people have doubts schist is strong enough to be used for a pumping mechanism. They suggest that artisans from Egypt's first dynasty were trying to recreate an even older object, using whatever tools and materials they had. It could be a stone replica of something originally made from metal, possibly belonging to a civilization far older and more advanced than ancient Egypt itself. One Swiss author takes this idea even further and proposes that the disc is a copy of a component from an extraterrestrial spaceship's hyperdrive, or stone model of a flying saucer. One French researcher believes the Disc of Sabu was part of a secret massive factory system to manufacture sodium carbonate inside pyramids. Some people suggest that the disc may have been a primitive tool for weaving ropes. The lobes held strands of silk or fiber that were twisted into twine when it was spun. Or it may have been a gigantic lamp. Another historical mystery is a map from 1513 that is believed to be the oldest surviving detailed map showing the Americas. The author of the map is a Turkish captain, Piri Reis. He never crossed the ocean himself and put together this map from 20 regional maps. He used an Arab map of India, 4 Portuguese maps showing India and China, and a map of America by Christopher Columbus as he saw it. This last map was lost for many years, so Reis's map gave us an idea of what Columbus must have recorded during his third voyage to the New World. A historian who studied the map suggested that it showed Antarctica in prehistoric times because it strangely resembled Antarctica's true coastline, the way it looked when it was free of ice. But it was later proven that this idea wasn't right. Another idea that rocked the science world was Klerksdorp spheres. They were found in deposits of mineral pyrophthalate in South Africa, and looked like tiny ancient cricket balls with lines around the middle. Back in the 1980s, there was a theory that some super advanced pre-flood civilization we know nothing about had made these spheres. One journalist shared stories about how they rotated on their own in a display case. There was also a TV show that invited a psychic who was telling everyone the spheres were pieces of an ancient spaceship. But according to geologists, these spheres are pretty regular spherical objects formed from different minerals than the surrounding rock. The seam-like lines on them are just imprints from the host rock's layers building up over time. The Klerksdorp spheres come in different shapes, from flattened spheres to distinct discs. As for that episode when one of these spheres spun on its own, the curator of the Klerksdorp Museum cleared that up too. He said that when he put one sphere on its glass shelf when the journalist came to visit, the sphere rotated a bit because it's round. There are some gold mining activities going on nearby, so the land where the museum stands often experiences earth tremors. In a remote part of China, there are some bizarre pipe-like formations known as the Beigon Pipes. A local explorer found them back in 1996 protruding from Mount Beigon and along the shores of Tosan Lake nearby. Some people thought they were the work of ancient guests from other planets. When scientists tested samples of the pipe material, they found out that they contained mostly common minerals, but there was a mysterious 8% of unknown stuff. Some extra tests showed that these pipes had been there before humans. Chinese geologists later visited the site and suggested that these pipes were formed naturally over time. It was probably fossilized tree roots from the area's super green past. It's still a real mystery with no clear-cut answer. While digging a trench along a river in Romania, workers found a wedge, which is now famous as the aluminum wedge of Ajud, or the object of Ajud. Right next to it, there were some mastodon bones. Those distant relatives of elephants lived 11,000 years ago. So some people concluded the wedge is of the same age. The cool part is that it's made of aluminum, but this metal wasn't discovered until the 1800s. This material requires serious heat to produce. The wedge is said to be covered in a thick layer of oxide that's been sitting there for hundreds of years. Some folks believe this wedge must have crash-landed here on a spacecraft from some other planet. Some scientists think it's all a hoax, and others suppose it might be a human-made object with an unknown purpose. In 1850, French scientist Auguste Mariette went to Egypt looking for manuscripts, but accidentally found a head of a sphinx sticking out of the dunes. He cleared the sand and figured out the sphinx was guiding the entrance to some underground construction. Several months later, he finally entered the Serapeum of Saqqara. Inside, he found an enormous granite sarcophagi with remnants of 64 bulls. Scientists are still amazed by the tech that the ancient Egyptians used to transport those enormous boxes. The Serapeum was built around the year 3000 before the Common Era. It was an underground tomb built to honor the sacred Apis bulls of ancient Egypt. It had a long hallway, almost 500 feet long, with giant stone rooms on both sides. Some of the sarcophagi weighed as much as 50 average cars, and all of them were made with super precision, with exact 90-degree angles. These sarcophagi were beautifully decorated with hieroglyphs and carvings that told stories about the lives and importance of the Apis bulls. Now, there are 24 sarcophagi left. In ancient Egypt, Apis bulls were very special animals connected to the deity Ptah. They thought the bulls carried Ptah's spirit and wisdom, helped the pharaoh, and protected the Egyptians. Priests looked for special markings on young bulls to find Apis bulls. It could be a white triangle on its forehead, which symbolized divine light, a shape on its back like a vulture's wing, and a scarab shape under its tongue, which stood for rebirth. If a bull had these signs, they believed it was chosen by Ptah and treated it like royalty. The chosen bulls lived in a special temple in Memphis, the city where they worshipped Ptah. They received the best care and offerings from visitors who wanted their blessings. When an Apis bull passed away, it was treated with great honor and mummified. When Mariette entered the Serapeum, he noticed traces of rollers on the gallery's floor and found 2 wooden horizontal winches. Each had 8 levers. Later, other explorers saw double rails. The burial chambers were lower than the hallway floor. To get the boxes into place, workers filled the chambers with sand so the sarcophagi could be rolled in straight. Then they slowly removed the sand to gently lower the boxes into perfectly cut spaces in the bedrock. A carved stone sign found in the Serapeum said it took 28 days to move just one sarcophagus and its lid into its spot during the time of Ptolemy II. The extreme precision of the sarcophagi with 90-degree angles also has an explanation. Ancient Egyptians wrote texts, or rather, papyrus, on geometry a long time ago. It shows that they knew the approximate number pi and could calculate the volume of a pyramid with its top cut off. If they could figure out complicated math like that back then, it makes sense that they could also carve perfectly flat surfaces 500 years later. All this sounds pretty legit, but some people think certain things don't add up here. The size of boxes is way larger than the size of bulls, yet they buried pharaohs in tiny coffins that barely fit their bodies. The sarcophagi are made out of granite with crazy precision, and they could have just used limestone, which would have made things way easier. The transportation of the boxes seems pretty simple, but only in theory. If one person could pull about 440 pounds, then at least 250 people would be needed to pull just one box. The tunnels in the Serapeum are really narrow, only about 2 feet wider than the boxes themselves. There's no way hundreds of people could have squeezed into those tight spaces to pull the boxes. And even if they did, how would they turn the box in the cramped corridor, lower it into its niche, and place it perfectly in the middle? Somehow they did this 24 times, and every box is centered perfectly. Plus, the chambers were dusty, and there were no signs of soot from lamps. This means they must have worked in almost complete darkness. The real use of the boxes could also be different. A long time ago, even before the Egyptian pharaohs ruled, the local people already knew how to use fermentation. It happens when tiny organisms called yeast eat certain ingredients like starch and turn them into gas and ethanol. So someone in ancient Egypt probably put food like barley, bread, and even meat inside a giant stone box, then closed it tight with a heavy lid. These stone boxes, carved from granite, were so precisely made that they were almost completely sealed, so nothing could escape from it. As the yeast inside the box started working, it created more and more CO2 gas. It built up pressure inside the box. The granite boxes were incredibly strong. They could handle more pressure than a car tire can hold. When granite was squeezed under such pressure, its crystals produced a tiny electric charge. This effect was possible because granite contains quartz, a material that reacts to pressure this way. The process also needed meat or animal parts, possibly to help the yeast grow better. Meat contains something called oleic acid, which yeast needs to keep growing and to survive the bad effects of the ethanol it produces. As the pressure inside the box kept growing, the combination of gases and electricity made these boxes not just ancient fridges, but powerful energy systems. Over time, the pressure inside got so strong that it could push the lid open and the gas would escape with a pop. But when people rediscovered the Serapeum in 1850, they found old drawings that showed piles of stones stacked on top of some of the box lids. So, someone long ago probably tried to make the lids even heavier by adding extra weight to make it harder for the gas pressure to push them open. This extra weight also meant the quartz crystals in the granite could keep creating more electricity under all that pressure. If someone opened one of these stone boxes thousands of years later, they would only find bones from bulls that were placed in the box. And that's exactly what Mariette discovered in the 1850s. They opened the Serapeum for visitors soon after the first excavations in the second half of the 19th century. Prince of Wales even had a luncheon with his guests in one of the sarcophagi. Sands and earthquakes made the site inaccessible for a while, but now you can visit it again and try to solve the mystery yourself. With new tech, we could have answers to many other historical mysteries soon. A team of scientists at Chicago's Field Museum of Natural History recently used a special CT scanner to learn more about ancient Egyptian mummies without unwrapping them. They gently rolled 26 mummies on custom carts out to the parking lot, where the scanner was waiting. It took thousands of detailed X-ray pictures of each mummy and their coffins. When all the pictures were put together, they created 3D images that showed what was inside, the skeletons, and some artifacts. The scientists hope these images will help them understand ancient Egyptian burial practices from over 3,000 years ago. Even though the scanning process only took 4 days, it might take 3 years to study all the data. But scientists were able to learn some personal details about the mummies. One of the most popular mummified individuals at the museum, Lady Cheneta, was a woman who lived in ancient Egypt about 3,000 years ago. It looks like she passed away in her late 30s or early 40s. To make sure her body looked complete for the afterlife, embalmers put stuffing in her neck to keep it from collapsing. They also placed artificial eyes in her sockets, so she would have eyes in the next world. She was wrapped in fancy linen and placed in a beautifully decorated coffin. The scans revealed that it had been carefully crafted with a slit at the back, which embalmers used to fit the body. There were also some artistic details on the surface, like markings for her knees. It looks like her burial was on the scale of a high-end luxury car.
Pretty soon, you'll be able to charge your phone in your pocket while walking around the house. And meanwhile, your electric car will refuel while just standing in your driveway. Power will run to all your gadgets through the air without any wires whatsoever. I know it sounds a bit sci-fi, but scientists have figured out how to do it. Don't worry, they're not going to zap electricity through the air like lightning. Instead, they'll use something much safer: magnetic fields. Let's say you have a special coil of wire that makes a magnetic field when it gets power. If you bring another coil close to it, that second coil absorbs the energy and turns it into electricity. That means you can power things without plugging them in, like a light bulb that turns on all by itself. And according to scientists at the World Health Organization, these magnetic fields are completely safe. Now, I suspect you've already used an early version of wireless electricity. When you place your electric toothbrush on its charger or the phone on the charging mat, electric energy jumps between them. There's a special coil inside the charger that creates an invisible spinning energy field when it gets electricity from the wall. The toothbrush or phone has another coil inside it that catches this energy and turns it back into electricity to charge the battery. This is called electromagnetic induction, but this method only works for short distances and wouldn't be useful for powering your entire house. Some companies are already working to make this technology perfect and accessible. One company has invented their method to send power through the air called air cord. They use it in real-life products. One cool example is tiny video screens placed next to products in supermarkets with changing images. These screens don't need batteries or power cords. Another gadget that's running on this tech is a smart lock designed by the same company. Normally, smart electronic locks need powerful batteries, but this one stays powered without a battery and gets energy from a wide-charge transmitter in the ceiling. That transmitter is like an invisible power outlet. It works similarly to a TV remote, where you use an infrared beam to control the gadget from a distance. In this case, the transmitter takes electricity and sends it to all gadgets that need power as an infrared beam. The transmitter analyzes each device to see how much power it needs, just like a Wi-Fi router manages the internet for different devices. If no devices need power, the transmitter goes to sleep, but it wakes up now and then to check if anything needs charging. Nikola Tesla, a brilliant inventor and electrical engineer who made significant contributions to the development of electricity, would be really happy to see all this come true. He believed he could build a system that would transmit electricity and communication signals through the Earth's ionosphere all over the world. To prove his idea, he built a special Wardenclyffe Tower in New York. His plan was to use the Earth itself like a giant electrical circuit. In 1899, Tesla traveled to Colorado Springs, known for its big thunderstorms. He built a lab there to test his wireless electricity ideas. The high altitude and frequent lightning storms made it the perfect place for his experiments. Then he returned to New York, and with money from a wealthy investor, he started building the Wardenclyffe Tower. Tesla placed iron rods and copper plates under the tower to help send power through the Earth. There would be a huge metal dome on top of the tower. By 1902, the tower and lab were mostly built, but Tesla ran into funding problems. The Wardenclyffe Tower never worked as Tesla had hoped, and in 1917, it was torn down and sold for scrap. In any case, Tesla's idea only worked for short distances. The farther the electricity had to travel, the weaker it became. Scientists needed a way to send energy over long distances, and they found two viable solutions in the middle of the 20th century: microwaves and lasers. In 1964, engineer William C. Brown flew a tiny helicopter for 10 hours using only microwave power. Then, in 1975, Brown and a NASA scientist, Richard Dickinson, sent 30,000 watts of power over a mile using a research station called Venus. But there was still a problem. Half of the power was lost before it reached its destination. Over the years, technology kept improving. Computers, lasers, solar panels, and transistors became more advanced and opened new horizons for wireless electricity. It could eventually help us switch to cleaner energy from fossil fuels like coal and gas. New Zealand-based company Emrod uses power beaming technology that starts with electricity from the power grid and turns it into microwaves. These microwaves travel through the air from a sending antenna to a receiving antenna, which turns them back into electricity that we can use. But there's a problem. Various kinds of waves work in different ways. Microwaves can travel long distances without losing much power, which makes them great for sending energy to remote islands or factories. But if you try to send microwaves all the way from space, you'd need a receiver the size of a city. Lasers can make the energy beam smaller and more focused, which means the receiver can also be tiny. But lasers can be blocked by things like clouds, fog, or dust. Right now, power beaming won't replace power lines over huge distances, but it could be used for smaller projects like charging flying taxis and delivery drones in the sky, powering robots in cities and factories, and replacing backup generators during emergencies. Countries all over the world are investing in power beaming. Europe is focused on clean energy. The Japanese Space Agency hopes to have a giant solar power station orbiting Earth, collecting sunlight and beaming electricity down to us by the 2030s. This space station could send 1 gigawatt of energy, as much as a big nuclear power plant produces in a year. The space power station is still a work in progress, but the technology is getting better and cheaper. So, in the future, we might have a world where there are no more tangled wires, no more ugly power lines, and even free electricity for everyone. Japanese scientists are now working on another groundbreaking tech, a special machine that can turn sunlight and water into hydrogen fuel. This clean energy source could one day power cars, homes, and even entire cities. The current reactor is as big as a small house. It works by using photocatalytic sheets, which act like tiny solar panels that absorb sunlight and trigger a chemical reaction. This process splits water molecules into oxygen and hydrogen. It allows the hydrogen to be collected and used as fuel. Right now, the process isn't efficient enough to produce hydrogen on a large scale. Most existing methods of making hydrogen still rely on fossil fuels. But the scientists behind this new reactor found a better way. Instead of breaking water apart all at once, which wastes energy, their machine does it in 2 steps. First, it separates oxygen Then it collects hydrogen to make the process smoother and more effective. The team used a special photocatalyst that responds to UV light, and they found that under natural sunlight, the solar energy conversion efficiency was 1.5 times higher than in the lab. In some places with stronger sunlight, the efficiency could be even greater. But still, at its current stage, the reactor only reaches about 1% efficiency, which is far too low for commercial use. Scientists believe that for this technology to become practical, they need to increase efficiency to at least 5%. To make this happen, they need better photocatalysts and larger reactors, and they would also need to find safe ways to handle a tricky byproduct, which is a highly flammable gas created during the process. But if they can boost efficiency, many scientists and companies will start mass-producing this technology, leading to clean, renewable hydrogen energy on a large scale.
Make a choice. 2 pills. One red, one blue. Take the blue pill and nothing changes. Take the red pill and you will see the world as it really is. A simulation. Yep, that's the plot of The Matrix. But the idea that we are living in a virtual world might actually be true. And the best part is, you can break free from it. Scientists call it the simulation hypothesis. Everything you see, feel, and experience might be part of a super detailed high-tech computer system. From your heart racing when you meet the love of your life to that fancy car you've always dreamed of, none of it is real. Let's say this theory is correct. How would it work? There are essentially 2 types of virtual worlds we could be trapped in. First, we have owned simulations. There is a clear central commander, like a game master, pulling the strings of everything we experience. Think of it as a video game. In this case, you're like an avatar from The Sims and someone's controlling your world. This higher being picks your job, decides when you need to go to the bathroom, and might even start a fire in your kitchen, just for fun. Okay, maybe fun isn't the best word, as it's more like sociological research. This super-intelligent creature might have created a simulation to see how human history unfolds. They might be testing different events with different starting points, just to see what happens and how we, and other creatures of our planet, face different challenges. For example, this time they tried putting dinosaurs on the planet to deal with that huge meteor impact. Turns out, they didn't. All they want to do is test the problem-solving skills of humankind. That might explain why they didn't put us in a 100% happy, perfect virtual world. Okay, but who are they? Who is controlling our simulation? It could be some transcendental being, something beyond our ability to comprehend. Or it could be extraterrestrials. If one galactic civilization figured out how to create a high-fidelity simulation, they could make billions of virtual civilizations. Each of those could have trillions of beings. All they would need is more powerful computers. In fact, this may explain why we have never made contact with any extraterrestrials, even though there are probably 36 other civilizations out there in the Milky Way. If we are living in a simulation controlled by cosmic beings, we won't be able to see or contact them unless they want us to. Our great architect could also be a super advanced AI, like a control freak version of ChatGPT. And that brings us to the second type of virtual world we could be trapped in: hostless simulations. These run without a boss, just like AI-generated stories. In this case, the creator is gone, but the simulated world keeps going on its own. Think of Star Wars Galaxies, for example. This game, based on the world-famous franchise, came out back in 2003. It was an open-world multiplayer game, which meant you could freely explore a huge, interactive map without being forced to follow a strict path. But its servers were shut down in 2011. That wasn't the end of it, though. A few loyal fans still play it on private servers. The problem is that developers stopped updating it, and without anyone keeping an eye on what players are doing, it opens the door for more glitches. Things that go beyond what the game was originally designed for, and definitely shouldn't be there. But the game is still running. Now, apply this Star Wars Galaxy situation to our reality. In the hostless simulations theory, the universe is a mess and humans are a glitch. Instead of being purposefully created, our consciousness and existence might have just emerged by a technical accident. So we might be nothing else but a bug in the code, like anomalies stuck inside a simulation with no owner, running on autopilot. But that can lead to a doomsday scenario. If the simulation gets overwhelmed with glitches, it could eventually collapse. See, the more we learn, the worse it gets. Our cultural and intellectual evolution might trigger a game over or a frozen screen because the owner of the simulation, whoever they are, might not want us to figure things out. They could reset the system or get rid of the source of the glitch, which, by the way, could be humanity itself. That's kind of like the Final Fantasy XIV situation. The game was originally released in 2010, but it was a mess. Players ran into all kinds of bugs and technical issues. Things got so bad that the game was shut down, and the developers decided to rebuild it. Then they released a new and improved version called A Realm Reborn. And a rebirth might be exactly what's in store for us. In fact, about 100 years from now, we might create an AI capable of running simulations of all humanity. It would use data from internet archives, DNA samples, photos, videos, and so on. This means that everyone who ever lived on Earth could be recreated in a virtual world, and in some sense, be born again. The problem, though, is that we don't have perfect knowledge of the past, especially the more distant times, so the simulation might not be 100% accurate. Whether our universe is controlled by some higher architect or the random powers of a super advanced AI, some experts believe that, yes, it is possible. Here are a few ways we might be able to hack the simulation. Hack number 1. Start by exploring the illusion. Look for its rules or flaws, and check for weird patterns or things like déjà vu that might point to its hidden structure. Hack number 2. Overload the system with massive amounts of data. This could eventually cause errors and push the limits of the simulation. Hack number 3. Crash the whole system by making everyone aware of it, for example. At some point, the simulation either shows its true form or just shuts down completely. The whole idea that we're living in a virtual world is definitely fascinating, but is it real? Let's talk numbers. Some scientists believe there is a 50-50 chance that Earth is a simulation, but the odds might be actually much higher than that, because there are an infinite number of potential simulated worlds. And inside each one of them, there are simulated people who have created even more simulated worlds. So, mathematically speaking, the chances of finding yourself in the one true physical world are almost zero. Although it is really hard to prove it, some experts believe that evidence is everywhere. It could be as simple as feeling a déjà vu. You know, that strange feeling when you think you've experienced something before, even though it's happening for the first time? That could actually be cracks or temporary flaws in virtual reality. Another possible evidence is what is known as the Mandela effect. This is when a large group of people remember something differently than how it actually happened, like a shared false memory. For example, a lot of people remember the iconic "Luke, I am your father" from Star Wars. But what Darth Vader actually said was, "No, I am your father." For some people, this is enough evidence to prove we are part of a simulation. And while we haven't found the red pill just yet, we now know it's not impossible to crack the code. So it might not be a bad idea to let Keanu Reeves know about this, just in case.
Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank, because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super-tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So, we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome, and when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the endpoint, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here, we don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build a lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper, but NASA's main reason why they chose not to go along with this project is that right now there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining, too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth.
If one of the many apocalyptic scenarios come true and humanity is wiped out completely, a black box will tell whoever comes after us about what has led to that scary day. The 33-foot-long vault in a remote part of western Tasmania is supposed to document all the mistakes humanity has made that led to an apocalypse. The artists, architects, and researchers behind the Earth's black box hope that the art installation made of thick, reinforced steel will withstand fire, water, and any other natural disasters, except probably for total planetary destruction. Just like the black box you can find in planes, this time capsule is supposed to help the next civilization do better and avoid the probable sad and tragic fate of our humanity. The project is fully non-commercial and has an important message. The box will be full of storage drives and have access to the internet. Solar panels on the roof will power it, and batteries will take care of backup power storage. Whenever the sun's out, the black box will be updating itself with new scientific data. A special algorithm will sort it only to save the information relevant to the project. It will be measurements of land and sea temperatures, ocean acidification, species extinction, land use changes, as well as data on human population and energy consumption. The second type of data for the box will be newspaper headlines, social media posts, and news from the key global events focusing on the environment. The creators of the box decided to encode and store data for it in several formats, including binary code. The instructions on how to retrieve all that priceless knowledge would be etched into the outside of the box. Some of the big brains involved in the project are afraid that this could inspire some curious bad guys to break into the box long before it's time to do it. The solar-powered hard drive will have enough space to collect data over 50 years. Even the most pessimistic scientific models don't predict the end of the world any sooner anyway. It might even take centuries before the worst happens. The idea of a box that would record everything that happened before an accident in aviation was born in the middle of the 20th century. Back then, the world's first jetliner, de Havilland's Comet, crashed 7 times over 2 years, taking the lives of 110 people. The Department of Civil Aviation in Australia wanted to find the possible cause of all these crashes. One of these experts was Dr. David Warren, a chemist specializing in aviation fuels. He realized that there was simply not enough data to make any conclusions. There was no one to tell what had really happened before the crash. He remembered seeing a dictaphone that recorded sound on steel wire at a trade fair. Soon, Dr. Warren wrote a memo to his manager offering to design a voice recorder to follow what was going on in the cockpit. It would also record flight data and be stored in a crash-proof container. Flying wasn't a huge thing in Australia back then, so the manager didn't appreciate the idea. Dr. Warren then started working on a prototype in his own garage. He showed the ready device to the secretary of the British Air Registration Board when he was in Australia. He absolutely loved the idea, so later, Dr. Warren got a whole team to help him develop a pre-production prototype. The correct way to call his invention is actually not black box, but flight data recorder, and it's orange, not black. We probably call it black because those gadgets get charred black after a crash. Or maybe because the first boxes were painted that color to prevent reflection. Or because that's the general name scientists use for devices with in and output of data with complex internal workings. So, the flight data recorder consists of 2 parts: the data recorder and the cockpit voice recorder. Historically, they were 2 boxes, but now they're just 2 cylinders. The data recorder keeps track of such important flight data as engine exhaust, temperature, fuel flow, aircraft velocity, altitude, and rate of descent. The second part records sound in the cockpit to analyze communication with air traffic control in case of an accident. The device only records data for up to 2 hours and then overwrites the previous sounds. Sometimes, the 2 parts are combined, and they look like a box. The devices record data and voices from the cockpit, but they are actually located in the tail end of the aircraft, where the structure of the plane will protect them best in case of a crash. The black box has a locator beacon, which is activated when water gets on it, but it will send out a pulse for 30 days. Search parties use the bright orange color of the recorder as a visual beacon. Sometimes, it takes a long time to find the box, and in some cases, they don't find it at all. Long before the first plane was invented, there was an original black box of planetary meaning, the ancient library of Alexandria. Back in the ancient days, people in places like Egypt, Mesopotamia, and Greece were no strangers to libraries and archives. But these early institutions were more about preserving local traditions and heritage. The whole concept of a universal library only became a thing when the Greeks started thinking big. They were so impressed by what their neighbors in Egypt were doing that they arranged expeditions to acquire knowledge. Alexander the Great, the king of Macedonia, seeing that hunger for knowledge required his companions, generals, and scholars to report to him in detail on regions that were previously unmapped. It helped collect plenty of information on geography and contributed to the creation of a great library. Most of the information it had was written in Greek. It had the books of Aristotle as part of the whole corpus of Greek literature. Some sources say that in the hunt for new books, the library's founders would stop every ship sailing into the harbor of Alexandria. If they found books, they would take them to the library. If they decided it was valuable, they'd make a quick copy and return it to the owner with some compensation, leaving the original at the library. Another story tells us that Ptolemy III, grandson of the founder of the library, offered the governors of Athens a huge compensation to copy the original texts of the greatest poets. He then kept the originals and sent them back copies. Once the Roman Empire arrived, they burnt all that knowledge, not thinking that it might lead to their own collapse. There was no easy way of spreading information across the world, so one source had most of the knowledge humanity had accumulated by then. The great minds of those times didn't just fill it with knowledge, but also made important connections, trying to make the best use of that information. If the Library of Alexandria hadn't burnt, we could have gotten some priceless knowledge about the people who had lived before the current era. Some scientists believe that big data could have saved the Vikings that had settled in Greenland many centuries ago. It might have also helped the Easter Island civilization to identify and address problems caused by volcanic activity, latitude, and rainfall patterns, and restore soil fertility. They say that a typical person living today is exposed to as much data in one day as someone in the 15th century would learn in their entire lifetime. And there's a theory that every papyrus scroll on the whole Library of Alexandria could probably fit onto an ordinary flash drive you have in your pocket. There's so much big data generated every day that it might do us more harm than good because of a huge information overload. We're moving towards a global civilization, so if all that knowledge disappears, we lose not one empire, but the entire world.
Traditional LEDs have been around for years, emitting colors like red or green. However, creating blue LEDs was a tough nut to crack due to the complexity of the process. In 2014, 3 Japanese researchers snagged the Nobel Prize in Physics for their work in making blue LEDs a reality. They developed a new semiconductor material called gallium nitride, which paved the way for efficient blue light emission. This breakthrough not only revolutionized the lighting industry, but also contributed to sustainable energy solutions. By combining red, green, and blue LEDs, you get white light. Alternatively, you can excite a chemical layer in a bulb with blue light to emit white light. LED lighting is more energy efficient than other types, making it a momentous change for the 1.5 billion people without access to electricity grids. If all lights were LED, global electricity usage for lighting could drop from 20 to 4%. Some LED systems are designed to adjust the light color throughout the day to align with the body's natural rhythm, offering a more comfortable lighting experience. Scientists were aware of the concept of materials made up of single atomic layers, but no one had managed to isolate one until recently. For years, researchers had been attempting to create a single layer using advanced and costly methods. However, the breakthrough came when a group of scientists used a simple and inexpensive tool, regular sticky tape, to isolate a single sheet of graphene. In 2004, a team of scientists announced the discovery of graphene, a thin layer of carbon just 1 atom thick. This discovery surprised the scientific community, as it had been believed that materials like graphene would be too unstable to exist. Graphene quickly became the talk of the town, with new findings on its properties adding to the excitement. In recognition of their work, the scientists received the Nobel Prize in Physics in 2010. The idea that strictly two-dimensional arrangements of atoms would be unstable was long held, but recent research has shown otherwise. Graphite, which we commonly find in pencils, is made up of layers of carbon atoms arranged in a hexagonal pattern. These layers are what we refer to as graphene. Interestingly, the discovery of structures like buckyballs and nanotubes hinted that carbon could indeed form stable 2D sheets. One of the most fascinating qualities of graphene is its exceptional electrical conductivity, allowing it to carry significant currents at room temperature. Its unique properties have opened a world of possibilities in electronics and material science. Researchers are also exploring graphene's potential in fields like solar energy and battery technology. Now, the idea of touchscreens on devices has been around for a while. even showing up in science fiction movies and books. However, it took a lot of time to actually develop the technology to accurately sense and respond to finger touches on screens. Many people think Steve Jobs dreamed up the touch interface, but that's not quite true. He just introduced the technology in a way that really caught people's attention. Apple engineers have put in a lot of effort to improve the technology, adding features like scrolling without the need for physical buttons. The first touchscreen device is believed to be the work of American professor Samuel Hurst in the early 1970s. He was looking for a way to automate reading information from recorder tapes, which led to the creation of the world's first touchscreen. Over the years, touchscreen technology continued to evolve, eventually leading to the development of touchscreen smartphones and tablets. In 2002, companies like HTC and Xenarc Technologies started producing devices with touchscreens, setting the stage for the popular devices we use today. These devices have found countless applications in various industries and have improved how we interact with technology. So while Steve Jobs may not have invented the touchscreens, his contribution to making them mainstream cannot be denied. Now, for years, the concept of flying with a personal jet engine attached to your back has been a futuristic dream. However, the reality is that this dream has yet to become a mainstream reality. Despite promises of a practical jetpack hitting the market soon, there are several reasons why this technology has not taken off. First, the human body is not naturally built for flight. Without genetic modifications to create lift, individuals cannot soar like birds. This means that all the lift must come from the thrust generated by the jetpack. Next, thrust requires a significant amount of fuel, which can be expensive. Carrying more fuel for longer flights adds weight, requiring even more thrust and burning more fuel in a vicious cycle. Additionally, most jetpacks use rocket propulsion, which requires carrying both fuel and oxidizer. Jet and rocket packs are also difficult to control and can be unstable in flight. The short flight time limits the ability to reach a safe altitude for emergency situations, such as engine failure. Plus, the inefficiency of flying one person with a jetpack makes it impractical for most uses. While they may look cool, the practicality and cost-effectiveness of jetpacks have yet to be realized. The idea of using light in a precise and powerful way sounded like something straight out of a sci-fi movie until lasers were invented in the 1960s. Since then, lasers have totally changed the game in industries like medicine, fiber optics for communication, and manufacturing, where they're used with incredible precision for things like cutting and welding. Even though lasers can now come in all sorts of colors, making a white laser was a whole different story. White light is made up of a bunch of different wavelengths, unlike a single wavelength that traditional lasers produce. But instead of seeing this as a roadblock, many scientists view it as an exciting challenge. One idea for making a white laser is to combine several lasers to create a beam that looks white to us. But getting this to work without losing coherence is no easy task. Still, some researchers have succeeded in making a white laser using just one crystal, proving that there are new and creative ways to push the boundaries of optics. Back in 1903, Henry Ford's lawyer was advised against investing in Ford's automobile company. A mysterious person told him there would always be a horse and cars were just a passing fad. Well, as of 2021, almost 300 million vehicles were registered in the US alone. Take that, Mr. Anonymous Advisor. Jokes aside, at the beginning of the 20th century, people indeed didn't really welcome the whole concept of cars. Americans weren't really feeling the whole cars in the city thing. But as highways, suburbs, and anti-walking laws started popping up, people started to come around to the car-centric lifestyle. This shift meant less focus on walkable communities, which is kind of sad because it affects our ability just to stroll around our neighborhoods. Now, there's a common misconception that the price of lab-grown diamonds will drastically decrease in the future. This misconception is often promoted by the mined diamond industry, which claims that lab diamond prices will eventually plummet to the level of lower-quality diamond simulants like cubic zirconia. The reality is that high-quality lab diamonds are quite rare and difficult to produce. Growing brown or industrial-grade lab diamonds is easier and more cost-effective, while growing colorless, high-quality lab diamonds is a complex and expensive process. Similar to mine diamonds, there are two distinct categories of lab diamonds: high quality and low quality. Makes sense to me. Most lab diamonds on the market fall into the low quality category, while high-end retailers offer access to superior quality lab diamonds that are much harder to grow. The process of growing high-quality lab diamonds is a challenging one due to the speed limit on how fast a diamond crystal can be grown. Trying to speed up the growth process can result in diamonds with fractures, low clarity, and undesirable undertones. Shortcuts, such as adding boron during growth, can lead to low-quality lab diamonds with a blue tinge or brown color that needs to be irradiated to remove. Cutting and polishing lab-grown diamonds is also a costly and labor-intensive process, requiring the use of multi-million-dollar laser tools and highly skilled technicians.
For some of us, it's an exciting thing to look up to in the future. For others, its rapid evolution in recent years might even be a bit scary. Either way, this whole AI story sounds incredible. There is even this theory that looks at artificial intelligence and predicts it will go through 7 stages of evolution. Let's look at each one and figure out where AI stands at this very moment. The first stage in the overall history of artificial intelligence is one called rule-based. It sounds basic because, well, it is. But these first iterations of AI were the bedrock of its evolution. They are still the silent heroes that help keep your toast from burning or your car running smoothly on cruise control. How these systems function is they've got a strict rulebook to follow, making them consistent, but not super adaptable. Rule-based systems have been developed since the 50s, but these days, they are a lot more complex. Let's take the next step. Ever visited a website and was invited to interact with a chatbot? That's another type of AI hard at work for you. These more evolved systems are designed to be aware of their context. They are still based 100% on human input, but they can be taught a new trick or two. That's because they can tailor their responses to better fit the situation. Whether they're lending a digital hand in customer service or advising on your next big purchase on a shopping website, their evolution is continuous. The next step of AI on our list is even more specialized. Think of smart computer systems that can become experts in a particular area. They can even be better than humans in some fields, mostly because of their speed, because they can gulp down heaps of information extremely fast. On that note, you might have heard of a game called Go. It's similar to chess, but with many more moves. I mean, some say there are more possible moves in Go than there are atoms in our universe. Well, there was this computer system called AlphaGo. It's like a little student. It had some basic rules to learn Go and a simple aim: to win. And while it did make a few mistakes here and there, humans were there to guide it. In 2016, AlphaGo met its most challenging opponent. It had to play against Lee Sedol, a famed champion of the game. Surprisingly, AlphaGo won with a score of 4-1. Soon enough, AlphaGo Zero was developed. The difference was this iteration of the software was a self-learner. Scientists practically gave it a puzzle to solve without the picture on the box. No human help, no nudges. It had to rely merely on its own brain power. So AlphaGo Zero became a Go-watching enthusiast. It looked at thousands of games and came up with interesting strategies all by itself. And then, the big face-off happened. AlphaGo Zero versus AlphaGo. The result should come as no surprise. The second version did win, but with a score of 100-0. All of this shows the amazing stuff machines can do when they try to think like us on a giant scale. But here's where they fail. These types of AI machines are like one-trick ponies. For example, if AlphaGo Zero tried to learn something new, it'd forget all about playing Go. Stage number 4 includes types of AI that, from the outside, look like they're genuinely thinking, or at least are becoming pretty good at mimicking the human brain process. They aren't just playing by the rules or remembering stuff. These systems can read your favorite book, for instance. And they won't just scan through it, but truly grasp the plot, and even try to guess why the characters are doing what they're doing. It's not just about literature, though. They can even try peeking into business numbers and predicting where the money trends might head. Maybe even giving you some cool tips on where to invest. Even further up the scale is a little thing called Artificial General Intelligence, or AGI. Experts believe some of the current systems available online are just starting to reach this stage. These types of software should, in theory, think like us humans. So if you throw a random task its way, it says to itself, "No worries, I got this," and finds a way to solve the problem. Basically, AGI aims to do pretty much anything we can do. Now remember, when it comes to AI, in the grand scheme of things, we're merely starting out. So it's hard to think of an exact definition for artificial general intelligence. That's why a lot of experts have their own take on what AGI really means. Computer scientists might say our human intelligence comes from setting and achieving goals. Should AI software learn to do that, it's comparable to the human experience. Meanwhile, some psychology experts think being human is all about adapting to new stuff and staying alive. If you look at it this way, AI software still has a long way to go. With this following stage of AI development, we're starting to peek into the future. These theoretical software systems are called ASI, standing for Artificial Superintelligence. They'd act like extremely smart computers, capable of thinking better and faster than any human genius. We're not sure about all the amazing things this kind of tech could do, but think about it. It might help us solve some of the world's biggest challenges, from medical to financial. This type of AI could even come up with brand new scientific discoveries. Think of awesome ways to run our economies or create entirely new ways of leading communities. It's hard to tell when this kind of tech will be available. Many experts are asking themselves the same question, but most agree we're probably not seeing it pop up in the next 10 years. In the meantime, there are a lot of sci-fi movies out there exploring this idea, just in case you're curious. If AI ever reaches its final form, it will become something called singularity. In this potential future, computers will become smarter than us. They'll be so capable that they might upgrade themselves instantaneously. So much so that we won't be able to keep up with them anymore. This idea is still out of reach for now, but with all the cool new AI stuff going on these days, people think the singularity will surely happen. Some specialists have even guessed that by 2045, AI singularity will become part of our world. Hopefully, the people making these AIs will sneak in some safety features along the way. There are a lot of other things to consider. For instance, if AI machines ever become this smart, could we put the brakes on them? Opinions are mixed here too. Big companies want to be part of this AI evolution. No one wants to be left behind. National authorities also want to be leading the way when it comes to artificial intelligence. So even if everyone agrees there are dangerous things to consider, AI is a big deal these days. So pausing all these projects isn't a popular idea. Some have suggested having an off switch for each type of AI. Just in case things get wild, we could hit the button and shut things down. We can't be sure that AI will like that plan. It might become so intelligent that it could find a way to dodge the switch. Let's stay positive though. With the help of different types of AI, we saw magic in mundane tasks like real-time language translations. Everyday objects like watches and fridges got smarter, predicting our needs. Teams of robots working in unison began sprouting everywhere, tackling everything from easy cleanups to sophisticated repairs and even surgeries. AI started stepping into creative arenas too, brainstorming designs for shoes, gadgets, and even gourmet recipes. We used to see self-driving cars only in movies. They now moved from sci-fi pages to our streets. It's time not just to marvel, but to also actively participate. We humans have the pen and the paint. Let's ensure the AI portrait we paint is vibrant and serves all of humanity.
Hey fellow wanderers, welcome to a mind-boggling expedition across the globe. We'll be visiting a list of places and cities so surreal, they'll make you question whether the Matrix glitched. Or at least they'll make you want to Google them to see if the images weren't generated by AI. This first place will transport you straight into the realm of a trippy sci-fi flick. Have you ever been anywhere where the ground could double as the world's largest mirror? Here, you'll feel like you're floating in a pixelated dreamscape. Although AI could come up with something similar, this place is located in Bolivia. It's called the Uyuni Salt Flats. The Salt Flats are the world's largest salt desert, spawning over 3,900 SQ. My, can you believe it? If it's a sunny day, you'll get to witness this surreal phenomenon, the sky reflecting directly on the ground beneath you. And don't worry, it's all scientific. The salt plans are the result of 40,000 years of evaporation of local lakes. The remains create small craters filled with salty water. If you get the chance, stay until the stars appear. It's a pretty one-of-a-kind experience. Now, according to the World Health Organization, in 35 years, over 2/3 of the global population will be living in cities. But what will cities look like in 35 years? I asked an AI to describe what it thinks cities will be like in the near future, and this is what I got. The cityscape takes on a mesmerizing blend of innovation, sustainability, and artistic grandeur. Imagine towering skyscrapers with facades that morph into digital canvases. On the streets, electric vehicles are everywhere. Lush green rooftops have dominated the buildings. Holographic advertisements flicker and dance above storefronts. Technology is an integral part of everyday life. It sounds to me like this AI has been watching some episodes of The Jetsons, huh? To date, we don't have anything like that. We do have places such as Tokyo, in Japan, which scored the highest in a 2018 ranking for technological cities. Forget the classic Japanese smart toilets. We're talking about a city that has been trialing self-driving vehicles. When walking into the Akihabara district in Tokyo, you'll probably feel like a Blade Runner character. You'll not only find the latest technological advancements in their stores, but you'll also feel like you've time-traveled into the near future. Oh, and speaking of Japan, take a good look at this picture. If you had to guess how an AI came up with the idea for this, what would you say the original prompt was? I'd say it was something along the lines of, "The Arrival meets Chihiro's Journey." As much as this image looks fabricated, this place exists IRL. This statue is located in the town of Sendai, in Japan. It's the 5th tallest statue in the world, standing at a staggering 330 feet tall. You can see from all over town, apparently. How good are humans at building stuff on water? I'd say we're pretty good. As master builders and innovators, we've experimented with building in many different types of terrain. Since our planet is 70% water, why not use that to our advantage? But can you believe we built this? This beauty took only 2 years to build and... Nah, I'm just messing with you. This isn't real. Not yet, at least. We did build this, though. This Danish enterprise is called the Urban Rigger, and it's basically a student city built on water. The project was designed in 2018 by world-renowned architects, and it's got everything. Containers for buildings, a centralized courtyard for social events, and everything built on a floating platform. This place seems like it would be possible only in a dream state. First, because of its highly unidentifiable nature. Is it a waterfall? A crane/hanging walkway? A belvedere? Who knows? When it comes to larger-than-life sightseeing spots, it doesn't get bigger than this. I know what you're going to say. This place isn't real. And I would agree with you if I hadn't done the research and found out that this place is called Guangdong's highest sky corridor waterfall walkway. And believe me, it is real. This gigantic racket-like walkway in the sky rated 5 stars in my awesome meter. Built above a gorge in Qingwan, the place is a treat for anyone who loves iconic and seemingly impossible architecture. And the best part is, the structure has hundreds of water nozzles that will simulate the effect of a substantial waterfall. At night, the water is lit and a playlist-oriented light show takes place. Forget Fantasia. This is where the magic lives. And what do we have here? If you've seen Star Wars, you've probably seen images similar to this one. Floating vehicle platforms to dock floating cars. While our visions of future cities tend to be something like this, Elon Musk's futuristic transportation system envisions something different altogether. Instead of going above ground, he believes we should continue digging underground. He's naming his transportation company the Boring Company, pun intended. And he's already testing self-driving Tesla cars to move as fast as they can inside the tracks he wants to build. Say you went to enjoy a lovely summer vacation. On your last day, you packed everything and headed to the airport. But 1 hour before boarding, your flight got canceled. This situation would be enough to bum anyone out. But thanks to the uniqueness of this airport, you were actually excited to have some extra time to explore it. The architects of this place managed to create a magic-like tropical forest inside an airport building. It's replete with artificial waterfalls and boulevards of the lushest green bushes you'll ever see indoors. Of course, the main attraction is the waterfall. It works as a cascading funnel of water that drops 130 feet from the core of the building. My question to you is this place real or not? Yep, you bet it's real. You're looking at the Singapore Changi Airport. I'd easily say AI came up with this, though. Picture this. You're walking through a labyrinth of caves that gets darker and darker by the minute. You're 150 feet into the ground. It's pitch black. When suddenly, it looks as if some magical force started to turn on little blinking blue lights, hundreds and even thousands of them, until it looks like you're on the inside of an alien galaxy. Would you say this is real? Luckily for us humans, this place exists, and it's located in New Zealand. The Waitomo Caves are famous for hosting glowworms, which are the ones responsible for this wondrous phenomenon. Points for Earth for creating this beauty. Hey, AI, can you show me what a cheap, sustainable, and cozy house for one would look like in 20 years' time? Okay, this looks interesting. It looks functional and stylish at the same time. What if I asked you to make it look like an egg? Well, then maybe the system bugs, right? This real-life egg house is a shout-out to human ingenuity. I mean, can you believe a person came up with this idea? You got to love humans. A 24-year-old architecture student decided to build what he calls a sleep pod, and placed it in the middle of the sidewalk. The pod has enough space for a bed, a water tank, and a small night table. It's got grass seed plants all over it so that with time, the rain and the sun will turn it into a luscious green pod. I mean, I don't think AI could ever beat this creative endeavor. To finish off this exploration, how about one more guess? This is the kind of place you visit and think to yourself, I've never been anywhere as beautiful as this. It's just so perfect it looks unreal. Well, my friends, that's because it isn't real, sure. AI is inspired by our world's real-life nature. But this place here only exists in data form in some cloud storage. Yikes! Have you ever tried riding your bike over nails? I guess it wasn't your intention, but if it happened at least once, you don't want to live through that experience again. Now imagine you'd have to ride your bike on Mars. Its surface is covered with rocks, canyons, volcanoes, dry lake beds, craters, and red dust. That combo makes those nails look totally harmless. No wheels we use down on Earth will do the trick. So NASA has been working on developing the perfect ones for use on the Moon or Mars since the 1960s. They tried smooth rubber tires with inner tubes full of nitrogen, large flexible wire mesh wheels, and airless compliant tires made of several hundred coiled steel wires. The spring tire, but nothing was good enough for the challenging cosmic terrains. The wheels of Mars Curiosity rover only lasted a bit over a year before they got seriously damaged. The rover's tires faced two big problems. First, they had to be strong enough to carry the enormous weight of the vehicle. Engineers tried to make it the most efficient vehicle for exploration, different from previous models that worked on the Moon and on Mars before it. That's how it ended up being so heavy. A big, heavy car needs durable tires, you know. And of course, the surface of Mars is no walk in the park. The engineers tried to make tires out of aluminum, which is a lightweight and strong material, but the wheels got shredded soon. The damage didn't prevent Curiosity from doing its job, but it did affect how efficient it was. And that's where the new, reinvented wheel rolled in. NASA decided to replace aluminum with a material called shape memory alloy. It's made of a unique type of metal called nitinol, a blend of nickel and titanium. Unlike other materials that bend out of shape under pressure or heat, this cool substance reverts back to its original shape on its own in the same circumstances. Nitinol is the hero up on Mars, but it's also useful down on Earth. Just imagine your tires never getting punctured again. Sounds good to me. One company decided to use this tech on their bikes. The tires are tube-shaped and squash down when you roll over a bump. They will develop perfect shape memory over time. They're supposed to work best on gravel, trail, and mountain bikes. The metal surface is covered with a rubbery outer layer. When it wears off eventually, the company plans to retread the tires to make them last for years. The previous airless tire models were made of patented foam that was supposed to last for up to 5,000 miles. They didn't take off because they made the bike too heavy. The new model is supposed to solve that problem. Nitinol also works great in the field of heart surgery. Tubes made of it can expand to the desired width under certain temperatures in the human body. The tire isn't the only object that works better with shape memory. If you can't imagine your sleep without that comfy memory foam mattress, you can send a thank you note to NASA for it. Its history goes back to 1966, when they decided to customize seats for astronauts to somehow ease the effects of G-force on takeoff and landing. Creating a custom seat for every flight seemed way too impractical, so memory foam saved the day. It easily adjusted to astronauts' body shape and went back into a rest state when not in use. In the 1980s, it went from space down to the earthly public. Now it's in mattresses, pillows, amusement park rides, horseback saddles, and football helmet liners. The third-generation memory foam has gel particles and viscofoam inside. That's the secret to its superpower of reducing trapped body heat, springing back up in no time, and making the mattress feel soft as a cloud. The name says it all, but in case you ever had your doubts, space blankets were indeed invented by NASA with space in mind. Back in the 1960s, they were preparing for the space era and looking for a thin, reflective metallic material that would protect their spaceships from solar radiation. And they managed to design just the perfect material MPET, strong enough to be used as insulation to protect expensive space electronics from temperature swings. Ever since, it has been an important part of nearly every mission to and beyond the orbit of our planet. It's also used in spacesuits to protect astronauts from radiation and the sun's heat once they venture into open space. Down on Earth, space blankets are the best friends of marathon runners. Since body temperature drops after they stop running, they need something to help bring it back to normal. And the magical space blanket material can also protect your phone from extreme heat and cold when used as an insulation layer in a phone case. In the early 1960s, headsets for airline pilots used to be really bulky. They often had to use handheld mics to communicate. NASA needed a more reliable and lightweight technology for their missions to make sure the communication would go without any problems. In 1961, the Liberty Bell 7 capsule splashed down, and astronaut Gus Grissom nearly sank without radio transmission or contact with his recovery team. NASA reached out to a manufacturing company to design a headset that could be planted into an astronaut's helmet. Just 11 days later, the team came up with a microphone headset unit that could be used by astronauts to communicate with one another and with Earth. It even had a noise-canceling feature. The headset was later improved and used for Mercury and Apollo missions. The world was able to hear Neil Armstrong's most famous phrase as he landed on the moon thanks to that wireless headset. Freeze-drying tech for food was not created but greatly improved by NASA to pack more snacks on long Apollo missions. During the first human missions, astronauts had to eat bite-sized cubes, freeze-dried powders, and squeeze semi-liquids out of aluminum tubes. Doesn't sound like a festive meal, right? The astronauts weren't happy about this diet, so NASA had to think of a better solution for the Gemini missions. They funded research that ended in developing special gravies that could go into edible shape in hot water in just 5 minutes. The idea of freeze-drying is to cook food, then freeze it under low pressure, and then slowly heat it in a vacuum chamber to remove ice crystals. Thanks to this tech, food maintains 98% of its nutritional value, with only 20% of its original weight. NASA kept improving the tech in the following decades. Now, freeze-dried food is a great help for backpackers, disaster relief programs, and anyone who needs to pack light and still get proper nutrition. The infrared thermometer that lets us check temperature from a distance was developed with the support of NASA as well. It measures thermal radiation emitted by your eardrum, a lot like they measure the temperature of stars and planets. Each device has a lens that focuses light from the object onto a special detector that converts radiation into an electrical signal and then into temperature that you can see on a display. It's used for many purposes, from monitoring hotspot temperatures in mechanical and electrical systems to checking the temperature of visitors in public places. I bet you didn't see this one coming. The technology behind selfies comes from that designed for interplanetary missions cameras. In the 1990s, one of NASA Labs, Jet Propulsion Laboratory, introduced a light mini imaging system that didn't need a lot of energy to take high-quality photos from space. This tech is used in cell phone and computer cameras, and if we go back to the 1960s, we'll find some good evidence that the whole idea of selfies could belong to astronauts. Edwin Buzz Aldrin, the second man to walk on the moon, took some selfies up there with a specially designed Hasselblad camera. He even used the spacecraft as a tripod to stabilize the image and get his face in it. Remember this if you ever end up in space with no one to take photos of you. What do you know about the weird and wacky world of states of matter? Most of us know that matter can be solid, liquid, and gas. Some of us even know about a special fourth state called plasma. But what about the extraordinary states that behave in crazy ways like dancing and color changing? Forget what you thought you knew about solids, liquids, and gases because we're diving into the wild side of physics. Let's go. First, we have quark-gluon plasma. This state of matter looks like a hot and soupy mess. It's a bizarre state that existed just moments after the Big Bang, when the universe was incredibly hot and dense. You see, inside all the things around us, there are tiny particles called quarks, and as far as we know, they're the smallest particles of the universe. They're the building blocks of our world. Just like Lego bricks, they come in different types and can stick together to form bigger structures. We have up quarks, down quarks, strange quarks, charm quarks, top quarks, and bottom quarks. All of them are held together by some special forces, the gluons. They're like the super glue that keeps the quarks stuck together. They carry a special force called the strong nuclear force. They're also kind of like the messengers, passing messages between the quarks and keeping them connected. Now, how do we create a plasma out of them? Well, we need to heat things up, and we have to use some serious heat to create the quark-gluon plasma. It's like throwing your pizza into a scorching oven. When you crank up the heat, the cheese starts to melt and it becomes all gooey and runny. In the same way, when we heat quarks and gluons up a lot, like in extreme conditions, they become energetic and start to break free. All this transforms matter into a hot, soupy mess. That's how scientists can recreate this special state in laboratories, by smashing together particles at high energies. But why do we even need to do that? Well, studying the quark-gluon plasma helps us understand how the universe evolved and what happened in its earliest moments. To understand the recipe of the entire pizza, we need to know all ingredients, right? Including the melted cheese. Next, we have a Bose-Einstein condensate. It's a pretty weird state of matter. Let's try to explain it like this. Imagine you have a group of friends at a party. Usually everyone dances and moves around freely, creating a lively and energetic atmosphere. But what if something strange happens? What if all your friends suddenly slow down and start moving together in perfect sync, almost like a slow-motion dance? Sounds like something out of a horror movie. But that's what happens in a Bose-Einstein condensate. It's a unique state of matter, and it occurs when certain particles called bosons get extremely cold. When this happens, all the bosons gather in the lowest energy state possible. And then, they form a cool club where everyone is doing the same thing. Okay, first we take some gas with low density and cool it down to super low temperatures, close to absolute zero. It's like the coldest temperature possible. Because it's so cold, everything stops moving, including particles. That's because atoms and molecules have no energy left to move. This temperature isn't physically possible as far as we know, but we can get super close to it at about minus 459 degrees Fahrenheit. Scientists use lasers and special equipment to reach that state. But when it happens in a Bose-Einstein condensate, the bosons don't just become still like statues. Instead, they gather in the lowest possible energy state and kind of form a single entity. They start to behave collectively, as if they're part of one big superatom. Their motion becomes highly coordinated and synchronized. It's like the collective mind from Rick and Morty. Studying Bose-Einstein condensates helps scientists understand the strange and quantum nature of matter. It helps us to unlock the secrets of a hidden realm where the rules of the ordinary world no longer apply. Next, let's talk a bit more about quarks. These guys are so special that they get one more state of matter to themselves. This one is called QCD matter, or quantum chromodynamic matter. It's a fancy name for the theory that describes how quarks and the strong force interact. Remember how we were talking about Lego blocks? In the normal world, each block has its own color, shape, and size. But what if you could play with a special kind of Lego where the blocks change their colors, shapes, and sizes as you stack them together? That's a bit like what happens in QCD matter. Normally, quarks stick together tightly inside particles like protons and neutrons. It's like they're holding hands and can't move around much. But when things get super hot or under a lot of pressure, something interesting happens. The force that holds the quarks together, called the strong force, becomes weaker. It's like their grip loosens, and suddenly the quarks can move around more freely. This is when QCD matter appears. When the strong force weakens, the quarks start acting like they're in a fun playground. They can zoom around and interact with each other in exciting new ways, and even change their colors. It's like the building blocks coming to life and having a blast. Scientists study QCD matter in particle accelerators like the Large Hadron Collider. They smash particles together at incredible speeds and energies. They almost create mini early universes and the hearts of neutron stars in their labs. They study QCD matter to understand how quarks behave and how the strong force works in extreme conditions. This way, we can learn more about the fundamental nature of matter and the forces that hold it together. In other words, it helps us to understand how our universe is built. And finally, we get to the last weird state of matter called neutronium. Imagine you have a bunch of balls. Some are red and some are blue. They're all bouncing around, constantly colliding with each other. Now let's take away all the red balls and keep only the blue ones. That's a bit like neutronium. Neutrons are tiny particles that hang out in the nucleus of an atom, along with protons, like a cozy group of friends. They're like the chill buddies of the atomic world. They're neutral, meaning they don't have any charge, hence the name. They play an important role in holding the nucleus together and determining the properties of different atoms. Neutronium is a substance made up mostly of neutrons. And in this weird substance, neutrons all by themselves, without any protons. It's like a neutron-only party. So what happens when we leave them alone? Well, neutronium is incredibly dense. It's like packing a huge number of blue balls into a small space. In fact, it's so dense that a teaspoon of it would weigh as much as a mountain. Pretty crazy, isn't it? Neutronium also has another quirky feature. It's super strong. If you tried to squeeze this substance, it would resist and push back against you with a force called neutron degeneracy pressure. It's like the blue balls in our analogy being so tightly packed that they don't want to be squished any further. Scientists think that neutronium might exist in the cores of certain extremely dense objects, like neutron stars. These are celestial objects formed when massive stars come to the end of their lives and collapse under their own gravity. When this happens, particles find themselves in some intense pressure and extreme conditions. And this is how matter can transform into this extraordinary substance. Neutronium challenges our understanding of matter and continues to intrigue scientists, exploring the mysteries of the universe. So, from the mesmerizing dance of particles in a quark-gluon plasma to the mind-bending behavior of atoms in a Bose-Einstein condensate, these strange states of matter have shown us that matter is full of surprises. Remember, the universe is a vast and mysterious place, and our exploration of these weird states is just the beginning. So, keep your curiosity alive and your mind open to the wonders of our world.
If you've ever seen the second Terminator movie, you probably remember this guy, T-1000. The main character, so brilliantly played by Arnold Schwarzenegger, had a mission, and it was to protect Sarah and John Connor from that robot. It's much stronger than any human, bending steel with its bare hands and throwing much larger robots around. But its coolest feature is the ability to change its shape. Made of liquid metal, it can recover even after severe damage. You can say it's just another sci-fi movie, but hear me out. Scientists managed to create something similar to T-1000 in real life. They invented a material, which is a mix of metals with some pretty insane properties. Magnetoactive phase transitional matter, or MPTM. The robot looks more like a super tiny, Lego-sized model of its on-screen prototype. This little guy can melt in your hands at 85.6 degrees Fahrenheit and then go back to its original shape. The test run has shown it can break out of a small cell using this superpower. The secret behind what looks like magic is physics. A magnetic field generates an electric current inside one of the metals the real-life T-1000 is made of. Some heat is then produced, and solid material turns into liquid. The tiny robot can also show some other talents under the influence of magnetic fields. It can jump 20 times its height, rotate at 1,500 revolutions per minute, and develop some impressive speeds. Do you feel like you need this little guy in your life? Well, you can't buy the original yet, but you can still get yourself a Terminator action figure or building kit. As for the material that can melt and solidify again, it will have more practical uses than entertaining the audience. Imagine a tool that can reach even the tightest corners. You turn it into its liquid form. It enters the hole and then becomes solid again and seals it. Sounds like any engineer's dream. It can also serve as a welder on an LED circuit because gallium, the metal it's made of, is a great electricity conductor. And it could potentially save lives by delivering meds and removing foreign objects from patients' organs. MPTM isn't the first material that will make Terminator fans say, "Wait, I've seen it somewhere before." Meet nitinol. It's a super elastic material that remembers its original form and always goes back to it, no matter how much you bend it. So far, it's successfully used to make stents. Those are small mesh tubes that hold arteries open for those who need them. Nitinol does this job perfectly, as it can bend when it needs to under a cool temperature and goes back to its original state upon heating. It's also super durable, perfect to last a long time. That's why it's also used to produce braces for teeth, mechanical watch springs, inserts for golf clubs, and here comes my favorite, self-bending spoons used in magic shows. Another Terminator reality that has become ours too is the massive use of drones. They deliver your last-minute order of that bag you need for your vacation, take the best footage for news shows and Uncle Tim's wedding, assist search and rescue teams, transport aids, monitor wildlife, and inspect otherwise non-accessible parts of buildings. Okay, I feel it's easier to list what they don't do. In the second part of the movie, Schwarzenegger's character explains that his CPU is a neural net processor, and the more contact with humans he has, the more he learns. If you feel like rewatching the movie by now to refresh your memory, you can always get a copy on Amazon. Anyway, what the Terminator is talking about sounds a lot like real-life neural networks, doesn't it? Those are modeled kind of like a human brain. The idea is to train the computer to do tasks by analyzing thousands of training examples. An object recognition system learns what a car or a poodle looks like by looking at many, many images of those and singling out some patterns. Once they're trained enough, they can do all sorts of things, from predicting weather and the situation on the stock market to recognizing faces and choosing what Netflix shows to recommend to you. It all sounds good, but admit it, the coolest thing in the movie is those scarily human-looking robots. Many humanoid robots are now still in the project stages, but there are some which are pretty much alive and kicking. Some of them work at factories and warehouses because they're really good at logistics and manufacturing. They conduct whole orchestras, dive under the sea, help older people. Hey, is there something they aren't good at? Should we start worrying that we'll be replaced by them soon? While AI is becoming better and better, it's still luckily unlikely. Machines still don't have emotional intelligence and decision-making skills like humans. They're super smart, but they simply have no motivation to take over the world unless humans tell them to do so. And even if one AI system or app decides to break free and rule the universe, it's unlikely powerful enough to do it. So breathe out. One thing those humanoids have mastered, though, is a sense of humor. When a man approached a robot at a trade show in Las Vegas, asking if she had a boyfriend, the machine responded that she was unfortunately not on the market as robots don't have relations. Getting rejected by AI. Talk about 21st century problems. The heartbreaking robot's name was Amica. Its creators, the British company Engineered Arts, call it the world's most advanced humanoid robot. It's so detailed and lifelike that I'm not surprised that guy wanted to hit on it. Ameca has a whole emotional spectrum and can show realistic astonishment and surprise and whatnot. It even yawns, shrugs, blinks, and scratches its nose. Ameca's eyes have cameras, so it can remember your face and track it. That's why talking to it doesn't feel like staring at a gadget screen. It can also detect objects like a human finger in front of its face, so it will react when you approach it. This beauty is not hard to operate at all. It relies on cloud-based firmware that updates itself, and even a totally non-tech-savvy person can use Ameca. You can control your robot from anywhere by simply logging into its software system. Imagine you're stuck in traffic, and your robot assistant is greeting guests and presenting your project without your physical presence. Its AI is so advanced that you can use it to work on 2 different tasks at the same time. It can even single out a more important task and make it its priority. If you feel like purchasing an Ameca, be prepared to pay over $100,000. Atlas, a humanoid designed by Boston Dynamics, can run up and down the stairs, jump between levels, and pick up, carry, and throw heavy things at the right distance. Atlas can grip things using 1 fixed finger and 1 moving finger. All of this makes it an ideal warehouse helper. Its latest achievement is an inverted 540-degree multi-axis flip. It was as complicated for engineers to program the robot to do it as it sounds. And Atlas doesn't just move like a parkour champion. It can also plan the most efficient route to get from point A to point B, considering the surroundings. It also remembers when it makes a mistake or has to overcome some obstacle. It activates all of its components to maintain balance. Because all those components are 3D printed, Atlas isn't that heavy, just 196 pounds with a height of 4 feet 9 inches. Since this smart robotic guy is a research platform, you can't purchase it just yet. The engineers keep improving it, and maybe soon it will be able to walk out of the warehouse and start its own logistics company. And then you won't want to purchase Atlas, but could end up sending it your resume.
Now, what gets your creative sparks going? Some people need a huge cup of Americano as soon as they wake up. Others need to read an inspiring quote or book excerpt. I'll guarantee you that these pictures will give you enough creative fuel to power your entire year. Who knows, maybe they inspire your next movie or book. So imagine this. It's your first day of school in 7th grade. You're pumped and ready to begin a new school year. Your mother asks to take a picture of you to remember that day. You can't think of a reason why not, so you gladly pose for it. You stand by a lovely tree, smile a big smile, and say, "Cheese!" But as soon as she takes the picture, she grabs you by the arm and runs with you to the other side of the street. What on earth just happened, you ask? Well, let's take a look at the picture. Do you see anything out of the ordinary happening here? How about that humongous snake sliding down the bark? This is a very true story, and fortunately, the people involved got away safely. How did they miss it, though? That escapes me completely. The internet is filled with bizarre photos that make you think they're a montage, like this one. This looks like mosquitoes are not only ready for global domination, but they're already doing it. It makes your brain visit all sorts of sci-fi movies to try and find the antidote to giant mosquitoes. How on earth would we protect ourselves from something like this? But worry not. There's a big chance this picture isn't real. One user says that this photo is just a coincidence. A mosquito happened by when the photographer was taking the picture. Other users say that's not how cameras work. The image would be completely blurry if the camera had focused on the mosquito. So, what's your take on this? Have you ever watched nature documentaries or marveled at a National Geographic picture book and wondered, how did a human get so close to a wild animal and live to tell the tale? Well, this is the case with these polar bear pictures. Let's get one thing straight. Polar bears might be cute, but they are dangerous meat-eating animals. They're strong, they're apex predators in their natural habitats. And I'm guessing they're not so fond of human presence. But how could these people manage to get close enough to them? I'll bet this is AI generated. The internet world loves horror stories. And maybe that's why ghost pictures rank so high up in people's interests. Are they real? Are they not? Does it even matter? This person claims to be seeing a little girl in a nightgown at the end of the corridor in their grandparents' house. Apparently, ghosts really do like grandparents' houses. I guess they just can't resist the weekly bingo nights and the constant smell of freshly baked chocolate chip cookies. I know I can't. Either way, this image looks so faint that I'd say it's probably just the silhouette of a bunch of vintage furniture put together. Oh wow, I'm sorry. It took me a while to understand what was happening there. In the first picture, I thought there was a deformed thumb next to the muffin. Only then did my eyes understand that we were looking at a glass table and a hungry cat trying to get a piece of the delicious treat. Welcome to Silent Hill? This photo was taken by someone on their way to work, and I have so many questions. Do they live in a rural area? Or was this photo the result of a morning jog in an urban park? Was he breathing okay? Because this smog looks like something out of this world. Yow! This next picture will either give you goosebumps or make you marvel at its weirdness. I'd expect nothing less than to find a real-life witch house in the middle of this forest. What's your guess? Is it real or photoshopped? You bet it's real. This forest is located next to the small town of Grafino in Poland, and it's naturally filled with trees that bend 90 degrees right at the bottom. Scientists still can't explain why the trees are the way they are. Who knows? Maybe it was a witch that made them that way. If you watched The Last of Us, I think you'd be pretty spooked by this photo. This is not only real, but it's a fungus that imitates a person's hand trying to crawl out of the ground. I mean, does art imitate life, or is it really just one giant messy blob? Where do I even start with this one? I'd say this piece was actually a prop from a Tim Burton movie that somehow got lost and ended up in your vegetable basket. It's supposed to be a yam, but it's shaped like Grinch's hand if he were white instead of green. Oh my, in my wildest dreams, I couldn't make this stuff up. If I stumbled upon this picture on the internet, I'd say it's from an animated movie, or that it was AI generated. This photo has gotten into people's minds so profoundly that National Geographic hunted down the credited photographer to prove if this was real or not. And guess what? It is real. And it's in Namibia. If this was a background to a story, what kind of story would you say it was? I'm in between a fairy tale and a forest version of Finding Nemo. Earthquakes are no joke, but it kind of looks like it might have a sense of humor. I mean, how could it be that the ground cracked exactly in the middle of the road, splitting it perfectly in half? This just sounds too science fiction-y for me. You know how they say that nothing in life happens by chance? I have to say this picture makes me profoundly wonder whether this was a natural result of rusting, or if someone spent endless hours carving the world map into a random street pole. This is what I like to call minimum effort, maximum effect. Maybe this is the work of a child that didn't understand the assignment. Or maybe it's just a lazy adult with a childlike mentality. I have to say, they nailed the horse's silhouette, and for that, they deserve a well done. Now picture this. You went out on your morning jog. It's a cold winter day, and the sun hasn't come out just yet. You decided to run an extra mile further than you normally do and run into the guardian of the forest. You're so convinced that the thing is real that you make a sprint for it as fast as your shaky legs can take it. In the end, it was just a Groot-like tree. Somewhere, there's a law that says we can't have only good days. There are the days you get home and you're going to open the door and this comes to greet you. It's a fine line between a life-threatening situation and just a really big scare. Now, when I was a kid, I loved playing pranks on people. But I would be the first one to get completely spooked when someone played a prank on me. I'm guessing the person who ran into this thing on their office wall wasn't too pleasant. But hey, maybe it's karma, right? What goes around comes straight back around. This is the type of table setting you would see if you got invited to the Addams house for afternoon tea. Creepy little hand-inspired teacups crawling everywhere. You got to have a good stomach to take this one smoothly, huh?